Well, hello, my friends. I hope you've had a very good week and you're very welcome to this week's project. Doesn't this look very clean? It is almost immaculate condition. I don't know how this lady kept it so well. It seems like it got very little use. But there are two problems with this. Number one, I do not have a power adapter. And I don't know what's happening with all of these. People just keep losing their power adapters. But there's no power adapter with it, so I'm going to need to inject voltage. That shouldn't be a problem. And the lady said that it just stopped working one day. It just wouldn't power on. So I'm going to have to inject voltage to find out what that issue is. And that's what I'm going to do next. The model number is, it's a HP Pavilion 14. It's got a Pentium Gold processor. I think there's only 4 gigs of RAM in it, so it's no way high end at all. And I'm going to post the model number underneath the video, the full model number, just in case anybody's interested. So let's get the back off it, take some pictures of the board and start to examine it.
To confirm, I've run the serial number of this HP Pavilion through the warranty check on the HP site, which is really handy, and it's told me that it's identified as a HP Pavilion 14 ce0507sa. Now this was bought in 2018 and then the warranty expired in 2019. I've just removed the motherboard and this is what it looks like. So the first task we need to do is to inject power onto the motherboard. Because we've no power adapter, I'm going to need to use my bench DC power supply to get power onto this board. So first question, what power do we need to inject? Well, the power we need to inject from the sticker on the back of the laptop is an input of 19.5 volts DC at 2.31 amps. So that's the power that I'm going to need to provide with my DC power supply because I don't have a power adapter. And the next question is, where do we need to inject that? Well, we need to find our DC power jack and our DC power jack connector. So if you look down here, this is the connector for our DC power jack. So there are 1, 2, 3, 4, 5, 6, 7, 8 pins on it. So how do we know where to connect our black wire and our red wire from our DC power supply? I'm going to show you next. With previous examples on this channel, when we've needed to inject power onto the motherboard using the DC power supply, we've been able to identify where to inject using a couple of methods. First of all, if we're doing a Toshiba, which would be something like this, you can see on the DC power jack where the wires are marked as red and black. So I know immediately that this is the ground wire and this is the positive. So all I have to do is follow those wires onto the motherboard, find the pins and inject voltage at these 2 points here. We also in some scenarios have had schematics where we'd had 1, 2, 3, 4, 5, 6, 7 and 8 and it identified those pins for us. However, I think if we've made progress at this point, we should be able to identify where to connect our black wire and our red wire from our DC power supply without any further assistance. So what I'm going to do is I'm going to put you a challenge at this point. So when I introduce my DC power supply and I put 19 volts on that, where should I connect my black wire to and where should I connect my red wire to? Based on the other examples that we've looked at on this channel, you should be able to identify. If you want to pause the video for a few seconds and see if you come up with the same answer that I did. Okay, so where we need to connect the black wire of our DC power supply is easy enough, of course, because we just need to find a ground, and the ground is everywhere. So we can connect here to here, here, or here. So that's where our black wire will go. But when connecting the red wire with our positive voltage, is there anything around here that looks like the other examples that we've seen of an input circuit for these types of laptops? Well, the answer of course is yes, because if we look right up here, what you can see is we have a diode right here, we have a MOSFET here, a second MOSFET here, and a current sense resistor. And this comes back to underneath our display connector right here, back to these 2 pins. So if you follow this, these 2 pins right here come underneath this connector across onto this diode, which seems to be a TVS diode for protection. This is our first MOSFET that is connected to our battery management IC. This is what's called an AC FET. This is the second MOSFET that's connected to our battery management IC, which they call an RB FET, a reverse blocking FET. And then we have our current sense resistor here. And our current sense resistor, of course, is a known resistance which we can use to determine what the current going into the motherboard is. So what I'm going to do is I'm going to find the ground at the nearest one of these points and connect my black wire to that, and I'm going to connect my red wire for my DC power supply right here, because we have a nice big piece of solder here that will be easy to solder a wire onto. I'm going to show you that next. Okay, let's do this. So we introduce our DC power supply. Now we saw from the back cover of the laptop that it was written down that the input for this laptop should be 19.5 volts. So I set my DC power supply to 19.5 volts. Just in case there is a short, I'm going to set a current limit of 0.5 amps. Now we just need to connect our black wire to ground, so I find the nearest ground, which is right here, so I solder a wire onto the ground there. And we've already traced our input from the 2 pins right here on the DC connector up to this diode here, and that is where I'm going to inject with my red wire, and that's how I've connected it. So now that I've brought power to the board, I'm going to show you what happened.
Okay, so I've got my 2 wires connected and we're going to press the power button and see what happens. So let's go. Boom. Okay. So we got a light coming on, and we don't have anything on the screen, but I'll give it a second. Uh-oh. What is this? We have ourselves an error code by the look of it. So what is that? Flash, flash. Let's do it again. 1, 2, 3. Okay, so 3 slow and 2 fast. Okay, I don't know what that is. Is it bias or something? I'm going to check that out and we'll see where we go from there.
I went back to the HP site and I wanted to get the exact list of diagnostic troubleshooting codes for this particular model. Now there is a number of documents here to do with this model, but when I went in and read through all of these, I could not find an LED diagnostic sheet for this laptop, so I had to resort then to a more generic search. So I used this search here: 3 long blinks, 2 short blinks, HP, caps lock. And when I did that, it essentially came up with 3 types of results for that error. So for 3 long blinks, 2 short blinks on a caps lock key, some people said it was the system motherboard, some said it was the BIOS, and some said it was the memory. Okay, now I did download the BIOS onto a USB recovery drive and plugged it in, and that didn't seem to do anything, so I don't think it's anything to do with the BIOS. So what I wanted to do next was just to check on the motherboard and make sure that there were no shorts on it. So that's what I did next. Now because the laptop power is on and our power button is working, I suspect that our 19 volts main power rail is good and our 3.3 volt secondary power is also good. But what I'm going to do here is I'm going to go around all of these inductors and take a measurement just to make sure that there's no shorts on any of our secondary circuits. Now, important thing here is to make sure that the power is off, and we then put our multimeter into diode mode, which looks like this on my multimeter. We place our red probe to ground, and then we can go around each of the inductors taking measurements. So let me just show you how I did that. So I get my black probe and I place it to either side of this inductor right here, again with the power off, and I measure 0.22. So that is not short at the ground. Up to the next one here, I suspect that these are our 3.3 volts and 5 volts power rails, but I'm going to place my probe here and I measure 0.3 volts, and to the one beside it, and I measure 0.31 volts. Then moving up to the next one here, I measure 0.02 volts. To the inductors up here, I measure 0.35, and the one beside it, I'm measuring 0.01 0.013. This inductor right here, I'm measuring 0.011. And then there is one more inductor over to the side over here. And when I measured that inductor, again in diode mode, I measured 0.3. Now what I'm looking for here is something really, really low. And really, really low would be like 0.001 or something like that. Even in the scenario where it is, you know, quite low, like this one, 0.011, I would tend to do a resistance reading at this point as well, and the resistance I was measuring there is 25 ohms, so that is not shorted. But what we can read from all of these is that it looks like none of our secondary rails are shorted, and you know, that's not what the problem is with this laptop. We don't have a short.
Back at my laptop, I decided to next look at the memory, which was also given as one of the possible reasons why you might get a 3 long, 2 short light on the caps lock. So I've removed the memory chip right here, and this is it. Now what I noticed was when I went to put this back in, the power is disconnected at the moment, by the way. When I went to put this back in, I hope you can see it here, it just seemed like it was very loose, that it didn't feel like it was pushing against anything. So I snapped it back in and I powered it back on, but there was no change. I also tried another RAM chip and there was no change with that either. I also tried cleaning out the DIMM slot and cleaning the whole area around the board, cleaning down the pins of the RAM chip itself. However, I decided to try one more thing because it just didn't seem like it was making a connection. I decided to press this down and hold it down to see if I could help it make a better connection, and then power on. And when I hold down the RAM chip, would you believe it? It boots and loads Windows. So that's the only difference there, is me pressing and holding down this RAM chip.
I'm trying to hold the camera steady here, but I wanted to get a look at this with my microscope, which I have to hold by hand to actually run along the line of this. But I want to see if there's any issues that are visible, to see why this, you know, why do I need to press and hold down the RAM in order to power this on. But let's go along the line and see. So I'm looking along. Doesn't seem like there's anything wrong with it, does it? That's the first section. And there's a second section there. No, I don't see anything. I don't see anything broken on it at all. Well, what I'm going to do is I'm going to swap out that socket and just replace it, and then I'm going to get a charger, and that should be it done. So that concludes my video for this week. We have a working laptop, but I'm not sure if we learned a huge amount. It's certainly a random sort of problem. I certainly have seen other HP Pavilion 14s online where they've got the same 3 long 2 short light code on the caps lock key, but in all those scenarios, replacing the memory chip, or the memory module as you might call it, has resolved the issue for those people. In this scenario, it seems like simply pressing down on the RAM chip in the socket is what gets it back up and running. And I don't know whether that can be wear and tear. It would be very interesting if anybody else had something similar with, you know, with memory on one of these, or with another similar model. This is PC4 memory. But if you've seen something like this in your experience, I would be very interested to hear about it below. So that's the video for this week. I hope you really enjoyed it. Please like and subscribe, and I will talk to you soon.